Hey everyone, so remember the last class we went over mostly numbers, such as significant numbers, exact numbers, and rounding conventions. Non-zero numbers are always significant, then any zero between two numbers or a number and a decimal is significant, then zeros before or after a number and decimal, there's like nothing else. You can theoretically keep putting zeros, then you'll hit nothing. Those are trailing and leading zeros, and those are not significant. Exact numbers have an infinite number of significant figures. The most common exact numbers are like whole numbers. Like I have 5 fingers. You cannot have like 5.5 fingers. You have to like cut one off in half, which you're not gonna do. And then we also did rounding conventions, where in physics it's rounding to the nearest even integer, not always just rounding up as we do in high school. And then when you're calculating, you have to like take into account the sig figs to determine your final answer, so you can remove the non-significant figures. So for multiplication and division, it shows you the number of sig figs by like, she says the most lame number, but it's the number that has the least number of sig figs. And then for the addition and subtraction, you go by the last significant decimal place. So at the end, and you remember she drew that line to show you where that division is. Something that I wanted to show you guys is a mnemonic that I used to use. It goes, King Henry died, I go by, the photo here says unexpectedly, drinking chocolate milk, and then my teacher showed me ... mu. The image shows ... so stop. Each one has a dot, making it. And this is just to help you remember conversion factors, right? The king is for kilo, the H is for hecto, D is for deca, etc., etc. The ones that you're going to use the most are the kilo, the centi, and the milli. And then basically every time you move, you're adding a zero or you're moving the decimal place in that direction. So I like to do it horizontally. And I should have a video. So, as I said, King Henry died by, the B is just for your base unit, drinking chocolate milk. I'm sorry that the voice is going to look different than the lips. I tried to record this at school and then realized I don't know how to do audio on my Chromebook. So this is the ... mu that I was telling you about, because that just, each dot is another zero added, and micro is a lot smaller than milli. So for example, if you were to have a 0.127 kilogram and you want to convert it to grams, you're going to start at the K, because that's for kilo, and then you want to get to grams, which is your base unit, so that's going to be where the B is. This would also be the same like milliliter versus regular liter and stuff like that. So then you're going to start at the K and move the decimal over 1, 2, 3 times. Or you could add 2 zeros to whatever conversion factor. So I'm going to show you 2 ways. There I'm moving it over 3 times. Note that you move the decimal over the same way you move it in the mnemonic. So if you start at the K and you move it over to the right, to the base unit, you have to move the decimal point to the right. But if you were to start at the base unit and move up to the K, that would mean you're moving to the left. So then you have to move the decimal from wherever it's starting over to the left. And then if you wanted to do it with conversion factors, you just have to usually divide it by, in this case it would be 1,000, because that's 1 and 3 zeros after it. Let's see if we can see. Yeah, 1,000 because 3 zeros. So then because you have kilograms, kilograms are bigger than grams, so you're going to have the kilograms at the bottom so they can cancel out. And then you're going to have 1,000 grams per 1 kilogram, so you're going to multiply whatever you have by 1,000. And that's going to give you the same answer as if you were to move the decimal point. And note that this is only for the metric system, because we do it a little thing different. So that's it for the mnemonic. And then these are just some units that we usually use meters, seconds, kilograms. In the next chapter, we're going to use velocity, meters over seconds, and acceleration, meters over seconds squared. I plan to do a lot of dimensional analysis with every equation that we get. I just wanted to introduce you guys to what that is. It helps you understand what the measurements are and what units you use and what unit you expect. So you would plug in like each symbol in your equation based on the unit that you know that symbol requires, and then you double check that you get the expected unit. So in this case for volume, you know length, width, and height are all distance, so then you use the unit meters. That's basically the same as x cubed or meters cubed, which is volume. For perimeter, you would add up like A, B, C, and D, the like lengths of the square, assuming that it's a square, they're all the same, which is the same as 4A, but your unit is meters. Your coefficient in front of it is the number that you're explaining with the meters, because units tells you what the number you have is like measured in. So if you're multiplying it, you don't basically you don't add the cubed or the squared to your unit unless the entire thing is already being cubed or squared. And then I just wanted to note that for density, because this caught me off guard, density in biology is usually grams per milliliters, right? But in physics, we use for mass kilograms and for volume meters cubed. And I just wanted to show you guys that it is indeed the same thing. It's just you have to convert to get there. And this is just a little conversion practice, because why not, right? You have the kilograms here. Those two are going to cancel out with those 1,000 grams on top, multiplying that, because that's the conversion that we remember, or that we got from that King Henry died by drinking chocolate milk. And then for the meters cubed, you can cancel those out, but for your 100 centimeters, because between the meters and the centimeters, there's going to be 2 moving over, or 2 zeros, you have to cube that entire thing. Because if in order to get centimeters cubed, you have to cube the conversion factor as well. And then centimeters cubed is the same as 1 milliliter, and that gives you grams per milliliter. And I believe that should be it for that. Yeah, that's for next time. And thank you for joining me.